Hey guys, today I'm going to teach you how to compare functions. By the end of this lesson, you should be able to determine and compare a function's rate of change from tables, graphs, and equations. So go ahead and get your binder, turn to the math section, and let's go ahead and take some notes. Rate of change should be a familiar word to you. It means the same thing as slope. And we can compare functions by looking at their slope and comparing that rate of change. Sometimes in equations, we'll just be able to point to the slope, but other times we'll need to find that rate of change. And we're going to do that using the slope formula, y minus y over x minus x, or we can compare the rise over the run. So we're going to go ahead and look at 4 examples that are very similar to these, and it's going to show you how to do those, so pay attention. If you're given an equation like this one, you should recognize that it's written in slope-intercept form. Slope-intercept form is that y equals mx plus b. M is your multiplier. It's always next to the x, and it tells you how you're moving. That's the slope. B is your y-intercept. It's where you begin on your graph. So looking at this equation, and it's written in the same form, I can tell you that the slope is 29/5. Or if I do 29 divided by 5, I get 5.8. Either one of those works. That is the slope for this equation. Let's apply that to number 1 on your page. What is the slope in this equation? The slope is 2/5. It's the number that's next to the x. It's your multiplier. It's how the graph moves. So if we want to write the rate of change, I can write that as the fraction, 2/5, or I can write it as a decimal because that might be easier to compare. So 0.4 is the slope on this first equation. Let's look at 2 more examples of problems that are not on your page but look just like them. We want to look at B and D here. These 2 questions involve using the slope formula, which is your change in y divided by your change in x. So let's look at it with the points. These are all set of ordered pairs. They're all x's and y's. We just need 2 points. I'm just going to pick the 2 that I like. I chose the ones with whole numbers. It doesn't matter which 2 you pick. We just need to plug them into our slope formula. Since every ordered pair is labeled x then y, I know that 12 and 17 are my y values, and I need to start with the y's in my formula. So I plugged in those numbers into my formula. Now I need to plug in their x values. Since I started with 17 in the formula, I'm going to start with 4, and then I'm going to do minus 2. Then I just need to go ahead and simplify this expression. I got 5/2 or 5/2, and it's probably easier to compare all these as decimals. 5 divided by 2 is 2.5. You can do the same thing in a table. Because a table is just a list of ordered pairs, it's just written like this. We're just going to pick 2 of these points and then use the slope formula. It doesn't matter which 2 points you choose. I chose the 2 whole number points. Now I'm going to go ahead and plug those into the formulas. It's y minus y over the x minus the x. Then you just simplify. I've got 55/10, and I know that that line means divide. So I can leave it as 55/10, or I can write it as a decimal, 5.5. So take what I just showed you about finding slope from points and from points in a table and try number 2 and 3 by yourself. Press play when you're ready to check. So you should have got 1.5 for number 2, and you should have got -3 for number 3. So far, just comparing the rate of change from 1, 2, and 3, number 3 actually has the greatest rate of change, even though it's negative. It's decreasing, but it's decreasing at a rate that's greater than 0.4 and 1.5. So right now, number 3 has the greatest rate of change. Let me show you how to do one more problem, and then we're going to compare all of the rate of change that we've looked at so far. When you're given a graph like in C, you can always count the rise over the run. You can count from point to point how many times it goes up and over. So I can see this point here and this point here. If I count up 21 and over 4, that is the slope, 21/4, 21/4. I know that that line means divide, so if I want to make it a decimal, I know I can also write this as 5.25 or 5 1/4. Let's look at number 4 the same way. See if you can tell me the slope all by yourself. Pause the video now and press play when you're ready to check. Since the slope goes up 1/4, you could have written 1/4. I wrote the rate of change to be 0.25. 1/4 and 0.25 are the same thing, both a quarter. So we just practiced finding the rate of change from a few different formats of functions. But today's all about comparing functions. So if I look at number 1, 2, 3, and 4, which function has the greatest rate of change? Number 3 has the greatest rate of change. -3 is decreasing, but 3 is bigger than the 0.4, the 1.5, and the 0.25. It's changing at a faster rate than the other ones. The slowest rate of change is the 0.25. It's the smallest number out of the 4 of these slopes, and if you look at the graph, it's not going to be very steep. Now let's compare the rate of change in the examples that I did for you. Using the labels A, B, C, and D, let's put these in order from the greatest rate of change to the least. Go ahead and try that now and press play when you're ready to check. All right, so A has the greatest rate of change. 5.8 is the biggest number. The bigger the number, the greater the rate of change. And if we were going to look at these on a graph, this would also be the steepest slope. But whichever way you look at it, whether it's a graph, a table, or an equation, we can always use the slope or the rate of change to help compare functions. So let's apply that to number 5. In number 5, we're comparing two people, Ty and Harrison. Ty sells signs at a monthly craft fair. He can make 7 signs every 2 hours. So we actually have Ty's rate. We do not have Harrison's rate, but we have some information in a table. Keeping in mind that Ty's rate is 7 signs for every 2 hours, Harrison's rate is all shown here in the table. He can do 15 signs in 4 hours, and so on. We want to know who is making signs at a greater rate. How do you know? There's a lot of different ways you can do this. Go ahead and try this by yourself, and then press play when you're ready to check. The way I did this is looked at how many signs they could make per 1 hour. Harrison has a rate of 3.75 versus Ty's 3.5. That's the slope. Or in this case, you could even call that the unit rate, because this relationship is proportional. 7 divided by 2 is 3.5. 15 divided by 4 is 3.75. You could have also pulled points from your table and used the slope formula. You would have still got the same answer. Or you could even look for a pattern like this. If Ty can do 7 signs in 2 hours, after 4 hours, he continues at the same rate, he would have 14 signs done. Well, Harrison's done 15 signs in 4 hours that same time. So you can tell right there that Harrison has done this at a faster rate. The second part of the question is, after 12 hours, what would be the difference in the number of signs that each friend has made? What is the number of signs that Ty has made after 12 hours? If he does 3.5 for each hour after 12, I can multiply those and get 42 signs made. Go ahead and do the same thing for Harrison. Figure out how many signs he's made after 12 hours. If Harrison's made 45 signs and Ty's made 42, what is the difference in the number of signs that they've made after 12 hours? There's a difference of 3 signs between them. Let's go ahead and look at number 6. We have 2 more people that we're comparing, and this time we're comparing the rate of them filling up their pools in their backyard. The equation that models the rate that Julie's filling up her pool is this right here. Elena's filling up her pool as well, but we don't know her equation. We just have a table that represents how many gallons are being filled up per minute. And our goal is to compare these 2 rates and determine which pool is filling up at a faster rate. And then how do we know? Let's start with Julie's equation. That's probably easier. You see a Y, you see a 5.2, an X, and an 8,400. I'm going to tell you right now that the X and the Y is the gallons and the minutes. So we're left with the 5.2 and the 8,400. Which one represents the rate of change? The rate of change for Julie is the 5.2. It's the M. It's the number that's next to the X. Remember, if your equation is written in slope-intercept form, you can just point to it. And 5.2 is the slope. 8,400 is the y-intercept. That's the starting point. That's the beginning point. That's how much water was already in her pool before she started filling it up. We can see that Elena actually has less water to start with. After 0 minutes, she has less water. But we're not comparing their y-intercepts. We're comparing their rates. So we need to determine the rate of change from Elena's table. How can we determine the slope from a table? We need to use our slope formula. So we're going to do y minus y over the corresponding x minus x. Now you should be able to determine Elena's rate of change, and you can decide whose pool is filling up at a faster rate. Go ahead and do that now, and then press play when you're ready to check. Hopefully you said that Julie has a greater rate of change because she has a bigger number as her slope than Elena does. Let's actually go ahead and skip number 7 now and look straight at number 8. Number 8 says compare the slope in this equation with the slope shown in the ordered pairs. Which one has a greater rate of change? So you're going to want to find the rate of change in the equation, the rate of change from the ordered pairs, and then decide which one is greater, the equation or the ordered pairs. Go ahead and try that all by yourself now, and then press play when you're ready to check. In the equation, I can see the slope is 3/5. And then after picking 2 points and using my slope formula, I got 6/10 or 0.6 or 3/5. You should notice that those slopes are actually the same. Let's compare the rate of change in one more example about Reese and Kevin. They're both working out and they're trying to lose weight. Reese's weight loss can be modeled by this equation. Looking at that equation, what is the rate that Reese is losing weight? Reese is losing 4 pounds a week because Y is the total weight and X is the number of weeks he's been working out. Kevin's weight loss is shown in the graph. So we need to determine the slope from this graph. We're going to do that by counting from point to point. Kevin started out weighing 200 pounds, and after 4 weeks, he weighs 180. Since the graph is linear, I can tell you that he's losing weight at the same rate each week. Go ahead and tell me, what is the rate that Kevin's losing weight? You can use your slope formula, or you can count down 20 over 4. 20 divided by 4 is 5, and since he's losing weight, it's a negative. So now we can compare who's losing weight faster. Explain your reasoning. Kevin is losing weight at a faster rate because he's losing 5 pounds per week. 5 is bigger than 4. So Kevin's losing weight at a faster rate than Reese. Alright guys, that's it. If you made it to the end of this video, I want you to tell me what exactly is the function of a rubber duck. Today we learned all about how to compare functions. Now you should be able to determine and compare 2 functions' rate of changes from their tables, graphs, or equations. So now you should go back to the calendar and click any other assignments you have left for the day. If you have any questions, bye!